Okay, so in this next problem, we're told that a statistics student wonders if tall women tend to date taller men than do short women. She measures herself, her dormitory roommate, and the women in the women in the adjoining rooms. Then she measures the next man each woman dates. Here are the data. All right, so here. Let me get my laser pointer. All right, these are the heights of these six women. This woman went on to date this man. This woman right here went on to date this man, and so on. These are those men's heights. So we're first asked to make a scatter plot for these data using women's height as the explanatory variable. Okay, so here's that scatter plot. Remember, women goes on the x-axis because they are the explanatory variable, and the explanatory variable goes on the x-axis. Um, do note that it's a little bit weird, I guess you could say, to call the height of women the explanatory variable, because it's not really having a major effect on the height of men. Because I mean, I don't know. It's not really clear how that causal direction is going. Um, if women's height is causing the men that they date to be taller, or vice versa. So it's not clear that it should be the explanatory variable, but they're telling us just assume that it is the explanatory variable, and so we will do that. So we've got this scatter plot. So like this dot right here, that represents this couple where the woman has a height of 71 and the woman has a height of 70 and the man has a height of 71. Now using this data, we're next asked to calculate and interpret the correlation for these data. All right, so when we're calculating correlation, we first have to take these scores and convert them into z-scores. Once we have done that, we need to multiply the corresponding z-scores together. Once we've multiplied and gotten those multiplication products, we then need to add those multiplication products up. Then after we've added them all up, we need to divide that added sum by n minus 1, where n is equal to the number of pairs, the number of couples in this case. All right, so I'll go through each of these steps. First, when we're calculating our z-scores, though, or converting to our z-scores, remember that the z-score is going to be equal to the original score minus the average divided by the standard deviation, which means that before we can even get these z-scores, we need to calculate our averages and our standard deviations for the women and for the men. So I'm going to do it for I'll calculate these for the women, and then you can do that for the men. I do have the answers for it, though. You can just do that calculation as practice. Okay, so here's our six women. All right, one has a height of 64 inches, another 66, and so on. To get the average, we just add all those heights up and divide by the total number of heights that we're adding up. So we have 6 heights that we're dividing up, so we'll divide that sum by 6 to get an average of 66 inches. All right, so we have our average. Now let's go ahead and calculate the women's standard deviation. So the first step is to subtract the average, 66. So we're going to subtract that 66 from each one of the women's heights. All right, so we have 66 minus 66 is equal to 0. The next woman is 64 inches, so 64 minus 66 is equal to negative 2, and so on for the rest of the women. Once we have these deviation scores, how much each woman deviates from the average, we're going to square each one of them. 0 times 0 is equal to 0. Negative 2 times negative 2 is equal to positive 4. Remember that every one of these squared deviation scores is going to be positive. That's the whole reason why we're squaring them to begin with, is to get rid of all negative numbers. All right, so we've squared each of them, and after we square them, we add up all of these squared deviations. scores to get our sum of squared deviation scores, or our sum of squares, which is 22. Once we have 22, our sum of squares, we divide by n minus 1. N is the number of scores, the number of women here, so we're going to divide 22 by 5, because we have 6 scores, so we're going to divide by 6 minus 1, or divide by 5, to get 4.4. And then finally, we can do the last step, take the square root of whatever it is that you got here. We got 4.4, so we take the square root of 4.4 to get a standard deviation of 2.10. All right. So for women, the average height was 66. The standard deviation was 2.10. For men, the average height was 69 inches, and the standard deviation was 2.53. Now, using that, we can convert each one of these scores into its corresponding z-score. Remember that z-score is going to be that score minus the average divided by the standard deviation. All right, so our first woman had a height of 66 minus the average woman's height, which is 66, divided by the woman's standard deviation of 2.10. When we do that, that's going to give us a z-score of 0. All right, for the first guy, he had an actual height of 72 minus the average male height, which is 69, divided by 2.53, the standard deviation, and that gives us a z-score of 1.19. Guys, when you're putting this in your calculator, put the 72 minus 69 in parentheses before, and then have that be divided by 2.53. All right, so do parentheses 72 minus 69, close parentheses, then divided by 2.53. All right, so we do that for each of these. To get all these z-scores, you can check each of those on your own. I've shown you the process. Okay, so for right now, I'm going to get rid of all this work and just show you the z-scores. So here's our z-scores. Now, once we have the z-scores, we need to multiply each pair of corresponding z-scores. I'm going to circle each one of those pairs right now. All right, so this makes sense, I think. This is the first pair. This is the second pair. This is the third pair, etc. And so we're going to multiply the two scores in each pair together. So I'm going to go ahead and do that. We should get these 6 different multiplication products. All right, 1.90 times 0.80 will give you a multiplication product of 1.52. 0 times 0.40 will give you a multiplication product of 0. So we've got our multiplication products. Now if you recall, and remember I gave you guys the steps on an earlier slide. The next step is we add up all of these multiplication products. Okay, and they all add up to 2.86. That is our added sum. Once we have our added sum, we're going to divide it by n minus 1. And n is the number of pairs that we have here. So we have 6 pairs, so we're going to divide 2.86 by 6 minus 1. We're going to divide it by 5. Okay, and so here's me showing that work being done. Divide by 6 minus 1, divide by 5, to give us a final answer of a correlation of positive 0.57. All right. So as the woman's height gets higher, the men's height is also expected to get higher, not shorter, because we have a positive correlation. We can kind of see that we would expect to have that positive correlation too. If we look at this scatter plot, clearly if we were to make a line, it would be a line with a positive slope. Okay, so question C asks us, what effect does the pair 70-71 have on the correlation? So what effect does this couple right here, all right, which is this dot. What effect does it have on the correlation? Remember that a correlation gets closer to either -1 or +1 as the dots get closer and closer to a line. All right, so if we didn't have this data point right here at all, our line would look just like this. It would look just like this. And what we can see is that this dot deviates significantly from this line. Right? If it were to be on that line, it would be much higher up. It would actually be like off the screen. So because it's deviating so sharply from that line, we know that what it's going to do is it's going to weaken the correlation. It would strengthen the correlation if it was on top of that line, but because it's very far from that line, it's actually going to significantly weaken the correlation. Okay, and the last question. How would the correlation change if the heights of the women were measured in centimeters instead of inches? Not one bit. The units that the variables are measured in has no effect at all on the correlation. So it would not change the correlation at all.